Hi, my name is Chris Knight, and I'm going to be doing a demonstration of the first extra credit assignment for engineering programming ENGR 267 at OIT for Dr. Mateo Aboy and James Eastham. The problem is a probability and simulation problem. It has to do with a movie theater line that has 200 people in it. The movie ticket costs $5 and people will pay with either a $5 bill or a $10 bill with equal probability. The simulation study is supposed to be how many $5 bills the cashier has to start out with initially in order to have enough $5 bills at all times with a probability of 95% for all 200 of these people to get through the line. And this is the script. It is a while loop that is testing the probability. It will continue to run while the probability is less than 95%. Within it is a for loop, that is the actual simulation loop. And it has a counter for $5 bills, and every time through this for loop, it increments the number of $5 bills that the cashier is starting out with. Inside of that loop is yet another, and this is the purchase by the person in the line, and it's using a rand_i function. And what that does is it produces a random integer that you can select, and I've selected either a 1 or 2 and arbitrarily given 1 to be a $5 bill and 2 to be a $10 bill. And that's supposed to happen with equal probability according to MATLAB documentation. And I'm testing the probability with the probability equation here, where we're dividing the number of successes by the number of experiments and incrementing the number of $5 bills here. And this is a display string that tells us a little bit of stats as we go, so we know what's going on. Right up here, we can select the number of experiments to run. I have arbitrarily chosen to run this simulation 500 times to see what the probability is. So let's give it a run. And here's our output. So when the cashier starts out with one $5 bill, the probability is only 10.2%. When starting out with five $5 bills, it turns out to be 107%. Four $4 bills is 74%. So this, with 500 tests run, we know that the cashier needs to have five $5 bills in order to have a guaranteed probability, or over 95%, or at least 95% probability of having enough. We can change the number of tests to run here. We can say run it only 100 times, and still the cashier needs to have, probability changes a little bit, but still, to get over 95%, the cashier has to have five $5 bills. This concludes my demonstration. Thank you.